In an AI-generated world, seeing is no longer believing. Enterprises need proof of who made a claim, where content came from, and whether evidence was altered. This lesson shows how cryptographic trust helps make identities, media, and workflows more resilient. We've moved from enterprise AI transformation into governance, security, compliance, and trust architecture. Now we build on identity assurance with verifiable credentials, content provenance, and deepfake-resistant workflows before turning to post-quantum readiness. AI changes trust because deception is no longer expensive or rare. A fake email, cloned voice, synthetic image, or deepfake can look convincing enough to pass a quick review. Enterprises need more than eyesight, headers, and instinct. Trust has to be verified through credentials, signatures, provenance records, and workflow controls. The question shifts from, does this look real, to can we prove where it came from, who approved it, and whether it changed? A verifiable credential works like a tamper-evident digital certificate. A trusted issuer signs a claim, such as identity, employment, certification, or permission. The holder stores it, often in a digital wallet, and later presents proof to a verifier. The verifier checks the issuer's signature and status, rather than relying on a copied document or database entry. This allows authenticity and integrity to be confirmed quickly, while reducing repeated lookups, manual review, and fraud. That credential remains trustworthy only if each stage is controlled. Evidence is checked first, then an approved issuer signs the credential. The holder stores it securely and shares only the proof needed for a transaction. The verifier checks the issuer, signature, status, and whether the claim fits the request. Trust also depends on cleanup. Revoked credentials must fail, and expired credentials need renewal before stale claims create risk. In the enterprise, verifiable credentials are not just for people. They can confirm an employee's training, a supplier's certification, a customer's eligibility, or a workload's authority to call an API. The pattern is consistent. Prove a specific fact quickly, without exposing extra data or forcing every organization to repeat manual checks. Content provenance is an asset's chain of custody. It records who created the content, what tools were used, when edits happened, and whether each step was signed. Digital signatures make later tampering detectable because a hidden change breaks the trusted record. This history supports more than authenticity. It also helps with audits, compliance reviews, investigations, and legal evidence. Emerging standards like C2PA aim to make this verification work across platforms and content types. Provenance should be treated as a chain of evidence, not a single label. Basic metadata such as creator, time, device, and edits is useful, but it can be copied or altered. Trust increases when that metadata is digitally signed, backed by trusted certificates, supported by platform logs, and confirmed by independent checks. Verification systems should treat gaps seriously. Missing signatures, broken chains, inconsistent histories, or unknown authorities should trigger caution before content is approved. Content authenticity also works best in layers. A digital signature is the strongest signal for integrity. It proves who signed the content and whether it changed afterwards. A watermark can label AI-generated or protected media, but it may be damaged by resizing, compression, editing, or deliberate removal. Provenance metadata adds history and traceability. In enterprise workflows, these signals should be combined with access controls and verification, so weaker evidence is reinforced by stronger controls. Imagine an urgent call from the CFO, followed by a matching email and a signed document. Each signal looks authentic, but together they create synthetic pressure. The payment team skips a callback, vendor checks are incomplete, and an approval moves forward. That is the enterprise deepfake risk. Not one fake asset, but a chain of weak verification points. Strong defenses redesign the workflow with independent confirmation, segregation of duties, and out-of-band approvals. Deepfake resistance comes from making impersonation insufficient. A convincing voice or video should not be enough to move money, grant access, or approve privilege changes. Require verified identity, known devices, signed approvals, and out-of-band confirmation through trusted channels. For high-risk actions, use dual control and transaction limits. Just as important, preserve evidence. Who approved, from where, using what credential, and under which authority. That audit trail turns trust into something testable. A trust decision framework turns "do we trust this?" into a repeatable policy question. The required controls should rise with business risk. Low-risk content may only need basic identity and metadata checks. Medium-risk workflows need stronger credentials, signed evidence, and verification logs. High-risk decisions require multi-factor validation, provenance checks, dual approval, and audit-ready evidence. The goal is not maximum friction everywhere. It is the right level of proof, applied consistently inside the workflow. Zero-knowledge proofs let a business verify a fact without taking custody of the sensitive evidence behind it. Think of proving you have the right key without handing over the key itself. A customer can prove eligibility, age, certification, or compliance status while records stay private. That supports data minimization and lowers privacy exposure. The opportunity is strongest across organizations, but adoption still requires careful checks on maturity, performance, interoperability, and governance. The goal is to make trust reusable, not project-specific. A trust fabric gives applications, AI agents, and content workflows common services for issuing, storing, signing, verifying, and proving provenance. It connects into existing IAM, PKI, key management, gateways, monitoring, and GRC systems, so verification becomes part of normal enterprise operations. Each verification should also create evidence: who checked what, against which policy, and when. Start with high-risk workflows, then expand the shared capability. The core lesson is simple. Future-ready trust must be verifiable. Credentials validate claims. Provenance and signatures protect origin and integrity. Deepfake resilience requires stronger workflows, not just better detection. From here, we look ahead to post-quantum readiness, where today's trust foundations must adapt to tomorrow's cryptographic risks.